formal charge. Under this aspect of Lewis structure, I'll be discussing about formal charge, and starting from the example that we have here, even from this board, the formula for formal charge I'll be using is very simple. Remember, those that offer CHM130, formal charge, they don't actually care the formula you use using this Lewis structure. Formal charge is valence electron minus bond plus dot. So this is B is bond and D is dot. Why this is valence electron? So what we are going to be talking about is formal charge. For example, using the Lewis structure from part 2 of my video, you can see here I can ask you to calculate the formal charge of the carbon in this structure. So for you to actually calculate the formal charge, you have to draw the Lewis structure first. And so from here you can see that the valence electron of carbon is 4, right? Now minus, when you come to the carbon here, look at this place. How many bond does this carbon here have? It have 4 bond. 4 plus, does it have any dots? No, it doesn't have any dots. Can you see it? It doesn't have any dots. So this place is 4 minus 4. Therefore, the formal charge on this carbon is 0. Are you seeing it? I can use this compound here, this compound that is on the board here, and actually calculate the formal charge of the sulfur here. So this is V minus bond plus dot. So the formal charge here, this is 6 minus the bond. How many bonds are surrounding this thing? We have 4. Do we have any dots around the central sulfur? Nothing. So this is it. So the formal charge, this is 6 minus 4, which is equals to plus 2. I can ask you to calculate the formal charge of all the elements here. Let me say I want to calculate the formal charge of here, this one, and let me call it O, let me call it A here. So the formal charge of OA here is the valency of oxygen is 6 minus the bond that oxygen have here is 2. Is 2, and it have also how many dots? 4 dots plus 4. And so this will give me 6 minus this plus this 6, and this will give me 0. Are you saying it? So this is how for you to calculate formal charges actually. So and formal charge is actually used to know how stable the compound is. Now let's go to the ones I copied under this formal charge. Let's say you have a compound here like this. After formal charge, all you have to get lone pairs of electron, because we're going to use it to solve a lot of things, especially during those exceptions of Lewis structure. You need to use formal charge to get it. Now, let's say you have this Rn, have this. Now, as we calculate the formal charge of the nitrogen, and though you know that this is this, so here the valence electron of the nitrogen is 5 minus the bond is 2 plus the dot, which is 4. So this is minus this, and this will give you minus 1. And so that's the valence electron, the formal charge of the nitrogen. Now, what if you have a compound like this? I have to calculate the formal charge, let me say, of the oxygen. The oxygen is still the same thing. We have 6 minus 3 bond plus 2 dots. 6 minus 5, this will give you plus 1. So that's how to calculate the formal charges of elements using this simple formula. Sometimes I can give you something like this. Let me show you how. Remember, in formal charges, you first have to get the Lewis structure. What if you have X, O, or you have a Lewis structure like this? So you have, and ask you to calculate the valence selection of all the atoms. Can ask you, very simple. It's still for valence. Let me say for sulfur, here is 6 minus how many bond? 3 plus how many dots? 2. So this is 6 minus 5, which is plus 1. So this one, let me say OL. For OL, oxygen at the left hand side. So I have 6 minus, the bond is 2 plus, is there any dot? Because we have, this is it. We have 4 dots here. We have 6 dots here, so plus 4. So this is 6 minus 6, which will give me 0. So for OR, the oxygen at my right hand side, I have the valency of 6 minus, how many bonds? I have 1 bond plus dots. How many dots? 6. So this will give you 6 minus 7, which will give you minus 1. So, and then if I ask you the total formal charge of this compound above, you can now see that here is automatically 0. So if I ask you to calculate the total formal charge, you will now see that this is plus 1 minus 1, which is equals to 0, because here automatically is 0. So they can give you a compound that has to calculate the whole formal charge. So this is how to do it. It's so easy. Now let me give you a classwork. Please drop the answer at my comment section. Please, very well, drop. What is the total formal charge of N minus? Or the total formal charge of N minus? Get me the total formal charge of NCN minus. Oh my God.